We're starting Module 3 with similarity. We talked about congruence. Congruence is when things are exactly equal, exactly alike. All sides and angles, all corresponding sides and angles are congruent. Now we're talking about similarity, which can be boiled down to basically kind of the same shape, but not necessarily the same size, as how it's often stated. We're going to look at that, though. We're going to start out with properties of dilations. The standard's 8GA3. We're going to describe the effects of dilations. Now, we've already done translations, rotations, and reflections in Unit 2. But we're looking at dilations, the effects of dilations on two-dimensional figures with and without coordinates. The objectives here is to determine the effects of dilations on side lengths and angle measures of similar figures. We're going to use scale factors to find side lengths in similar figures. Okay, the activities here is we're going to be in Eureka, Module 3, Lesson 1. This is the workbook, okay? And I can't very well put in the video in this particular location because I'm making it right now. Okay, in a pair of figures, now this is just guided notes we're taking here. In a pair of figures, angles in the same relative position are called corresponding angles, okay? Corresponding angles. So let's write that in. We're just trying to get some terms that we can understand. If they're in the same relative position, they're called corresponding angles. Now let's look at this. That means if you've got parallel lines and a transversal, we talked about corresponding angles here, didn't we? We talked about if you went through the red lights in town, if you're coming from Baton Rouge, you get to the first red light there in town, then you would see the Francis here on this corner. If you went farther out, you'd see Burger King in the same relative location. Those are corresponding angles. Well, now we're going to talk about corresponding angles in figures. For instance, if I'm looking at these two figures here, angle A is in the same relative location as angle X. Angle B is in the same relative location as angle Y. And angle C is in the same relative location as angle Z. Okay? They're all in the same relative location. Corresponding sides. In a pair of figures, sides in the same relative position are called corresponding sides. Okay? So let's talk about which sides are corresponding here. AB. And what does AB correspond to? It's in the same relative position as XY. Those are corresponding sides. BC, let's see what it's in the same relative position as. YZ. Okay. And AC is in the same relative position as XZ. Okay. There we go. Now let's look at down here. We're going to talk about what happens when you've got corresponding angles in similar figures. If you have tracing paper, you can put this over here and trace off this angle right here. If you translate it over here, what you're going to see is these two angles have the same measure. They're going to be the exact same angle measure. You would have the same situation here. If I move this over here, these would have the same measure. Same here. If I move the paper, trace off this angle, move your paper over, you're going to see, and lay it on top of this one, you're going to see that they have the same angle measure. So what do you notice? Using patty paper, you notice that corresponding angles in similar figures are congruent. Okay? Corresponding angles in similar figures are congruent. Okay? Now let's look and see what happens in corresponding sides. If we're talking about corresponding sides in similar figures. to put some numbers up here in this. Hold on. Let me get you some numbers in here so you can see them. If you've got this triangle, this side is 3, this side is 4, and this side is 5. If this side corresponds to this one, let's say this is 6, 8, and 10, okay? Now, let's talk about the lengths in these corresponding sides. They've got us a place to put them here. The length of AB is 3. The length of BC is 4. The length of AC is 5. The length of XY is 6. The length of YZ is 8. And the length of XZ is 10. Okay. Now, what I'm going to do is I'm going to set us up some scale factors. We need to see if the sides are proportional. So let's set up some ratios of the sides, okay? Now, I want to talk about scale factor first because this is going to help us understand these ratios. The scale factor, when we are creating a dilation, is equal to the length of an image side over the length of its corresponding pre-image side. Okay, image over pre-image. In this case, this is our pre because it's what we start with. This is our image because this is what we end with. Pre means before. We did this when we were doing congruent figures. Now, let's look at AB and XY. AB and XY, they're corresponding sides. This is my image side, this is my pre-image side. So I'm going to put those over each other to find the scale factor between those two sides. And the scale factor between those two sides is 2. 6 divided by 3 is 2. Now let's do the same thing with another set of sides. How about YZ and BC? Okay, YZ is 8, BC is 4. 8 divided by 4 is 2. Okay? How about this one and that one? I've got 10 and 5. 10 divided by 5 is 2. Okay? All of these are the same. All of these are equal. Hence, what we're looking at is the scale factors are the same. If the scale factors are the same, then these figures are similar. If the sides are proportional, now let's look at what sides are proportional would mean. 6 over 3 to 6 over 3 equal 8 over 4 equal 10 over 5. Yes, it does. That's 2 equal 2 equal 2. Yes, it does. Okay? So hence, these are all the same. Okay? Therefore, those figures are similar. So if two figures then are similar when corresponding sides or corresponding angles are congruent, and corresponding sides are proportional. Okay, so let's see if these are similar. We're starting with A. It's our pre-image because this is anything similar to rectangle A. This is our pre-image. Okay, we're going to compare these other two and see if these are images. Now, we know the corresponding angles are congruent because if it's a rectangle, this one's 90, this one's 90, this one's 90, this one's 90, and all of these are 90, and all of these are 90. So we know about the corresponding angles are congruent. Let's check to see if the corresponding sides are proportional. Okay? And I like to set it up in our scale factor formula. Scale factor is equal to the length of an image side over the length of a pre-image side. Okay? Image side over pre-image. Okay? Now, our image in this case, let's try B. We're going to try B and see, is it similar? Is it similar? If it's similar, then the sides will be proportional. 6 and 6 correspond to each other. There's your image over your pre-image. 2 and 3 correspond to each other, okay? Notice, in each case, I put image over pre-image, image over pre-image. 6 divided by 6 is 1. This is 2/3. These are not equal. So therefore, these are not proportional. They are not similar. This is not similar to to rectangle A. Not similar. Why? Because the sides are not proportional. Let's compare C to A, okay? This was B to A. This is going to be C to A. Let's compare and see if these sides are proportional. C. Corresponding sides, 4/6. Is that equal to 2/3? Let's reduce 4/6. Let's divide that by 2/2. And if I get that when I reduce it, I've got 2/3. Is 2/3 equal to 2/3? Yes, it is. So since this one is similar to rectangle A, okay? Why? Because the sides are proportional. Now, let's look at these and let's see if we can't find the side lengths, okay? We're trying to decide the shapes below are similar. Use this information to find the value of x. Well, if these are similar, then I should be able to set up a scale factor. The sides will be proportional. Remember, we talked about scale factors. Scale factors is equal to the length of an image side over the length of a pre-image side. Here's our pre-image, here's our image. I'm just going to name them that way because this one came first, this one came second, and there's nothing to say that they're any one particular one is the image or the pre-image. I get the same answer either way if I'm just trying to find a side length. Okay, so let's set up the image versus the pre-image. The image side here is 9. What would be its corresponding side? It would be 6, okay? Now we're trying to decide if these are equal, if these ratios are equal. This is x, that's 8. X over 8. There we go. 6x is equal to 9 times 8, which is 72. We'll divide both sides by 6, and x will be equal to 12, okay? Let's look at number 2, okay? If I've got this one. Same situation, this side is 12. Now let's see if that makes sense. 9 is bigger than 6, 12 is bigger than 8. That makes sense. So let's try this, pre-image and image. Okay? 9 is to 6, as 6 is to x. 9x is equal to 6 times 6 is 36. Let's divide each by 9, and x is 4. There you go. X is 4. Let's see if this works. 9 is bigger than 6. 6 is bigger than 4. So that would make sense. Now let's look at number 3. Okay. And I've looked straight at this one. Look at this, guys. If this one started at 14, it winds at 7. Doesn't that tell you up front you're dividing it by 2? Isn't this half the size? But let's just go ahead and work it out. Now, this is my pre-image and this is my image. 7 is to 14 as 12 is to x. There is 7x is equal to 12 times 14. If you multiply 12 times 14, you get 168. Let's divide both sides by 7, and x is equal to 24. Now let's see if that makes sense. 7 is half of 14, 12 is half of 24. That does make sense, okay? So those were just warm up. Let's go to the actual workbook. This is workbook page 1, okay? They ask you, says two geometric figures are said to be similar if they have the same shape but not necessarily the same size. Using that informal definition, are the following pairs of figures similar to one another? Explain. Same shape, not the same size. That would look like it's similar. Pair B, this is a rectangle. This is a rectangle. This is a square. They don't have the same shape. Not similar. They're not the same shapes. Okay, pair C, these are similar because they've got the same shapes. In fact, they look like they're the same size. Okay, they may be congruent. We don't know. These are the same shapes, but not the same size. That would be similar. Go to the next page. These look like they're the same shapes, but not the same size, so they're similar. These are the same shapes, but not the same size, so they're similar. And we're going to leave out G and H because there's some other things we're going to deal with on G and H, okay? Let's look at the exercises down here. Given the absolute value of OP, line segment OP is 5 inches. So if you're looking at line segment OP, from here to here, it's 5 inches long, okay? If it's dilated by a scale factor of 4, what's the length of OP prime? This would be my image because it's got the P prime on it. P prime. Okay, we want to know how long OP prime would be. And if it's 4 times what this was, that would be 5 times 4, which is 20, okay? This is 20 inches long, okay? B. OP. Let's start with OP is 5. OP, which is 5. Dilate by a scale factor of 1/2. That means I multiply this length by 1/2, and I wind up with OP prime of 2.5. 2.5. Okay, that's half of that. 2.5. Okay. So let's look really quickly at scale factor itself. Your scale factor is equal to the length of an image over the length of a pre-image. Well, if this is the pre-image and this is the image, then whenever I work this out, it's 8/2, which is 4, okay? So that means that this one has been multiplied by a scale factor of 4 to get you 8. Here you go. Here's this one, a length of a pre-image to an image. That's 12 and 4, okay? Now, image goes over pre-image. 4 divided by 12 would give you 1/3. This is 1/3 the size of this one. Notice, if I am using a scale factor of something greater than 1, it's going to get bigger. If I'm using a scale factor of something that is a fraction, it is going to get smaller. What if it has a scale factor of 1? Then it shouldn't change, should it? Okay, it should simply be 1. Okay, now let's look at this one. This is workbook page 3. Use the diagram below to answer questions 2 through 6. Let there be a dilation from center 0, then dilate P such that it becomes P prime, and dilate Q such that it becomes Q prime. In the diagram below, OP is 3 centimeters, OQ is 4. If the scale factor is 3, what's the length of segment OP prime? Here's your P prime. If OP is 3, and I'm going to OP prime, I'm multiplying by a scale factor of 3. 3 times 3 is 9. The length of the segment is 9. Okay? How can I prove that? Use the definition of dilation to show that your answer to 2 is correct. Scale factor is equal to the length of the image side over the length of the pre-image side okay? So in this case, our scale factor was 3. Let's plug these things in, substitute where we can. We're looking for the image. Our pre-image is 3. We can cross multiply, and x is equal to 9. Okay, 3 times 3 is 9. If the scale factor is 3, what's the length of segment OQ prime? You started with 4, multiplied it by 3, and you get 12. Started with 4, multiply it by 3, and you get 12. Okay? Use the definition of dilation to show that your answer is correct. Well, if our scale factor is 3, we know our scale factor is equal to the length of the image side over its corresponding pre-image side. Okay? The scale factor was 3. We don't know what our image size is because that's what we were looking for, OQ prime. OQ though is 4. So the pre-image is 4. We're looking for this. Okay? X is equal to 3 times 4, which is 12. Okay? If you know that OP is 3 and OP prime is 9, how could you use that info to determine the scale factor? Let's use the formula. Scale factor is equal to image over pre-image. Okay, the scale factor in this case is 3. Okay, that's equal to the length of the image, which is 9, over the length of the pre-image, which is 3. Now look, if you didn't know what the scale factor was, and you put in the length of the image over the pre-image, that would give you your scale factor, which is 3. Simple enough. Okay? Now, this is on workbook page 9. Let there be a dilation from center O. You're going to start with OP, and it's going to be dilated to P prime. This is P prime. You're going to start with Q, and this is going to be dilated to Q prime. Okay? Examine the drawing below. What can you determine about the scale factor? Well, if I start with the shorter line, this OP, and then I wind up getting this longer line, OP prime, okay, then I know I have made this longer. I have made it bigger. My scale factor is going to be something that is greater than 1. Because remember, if it's 1, it doesn't change sizes. If this were 2 and I multiplied it by a factor of 3, that would be 6, right? If you multiply it by a number that's bigger than 1, it's going to get longer. That's what this one did. On this one, there's a dilation from O. Your dilation, you're starting here. You got OP. This goes to OP prime. All right? I'm now making it shorter, right? I start with OP. After I dilate it, it's going to be shorter. You know, if you dilate something and you make it shorter, am I multiplying it by a number that's greater than 1, or multiplying it by a fraction? You're multiplying it by a fraction. So your scale factor is a fraction. It's actually a positive fraction, okay? A positive fraction. Let's put it that way. A positive fraction. Okay, think about it this way, guys. This is a fraction of the length of the whole thing, right? This is a fraction of what you started with, okay? And then let's last thing down here at the bottom. Here's your thing. You got a scale factor of 4. Okay. We need to dilate this, okay? OP, scale factor is 4. I'd simply multiply 4 times 3.2. How much bigger will it be? That's 12.8. This OP prime would be 12.8. If OQ is 2.7 and we're multiplying it by a scale factor of 4, what do we get? 4 times 2.7. 10.8. Okay, that covers everything. We have looked at scale factors. We have looked at the fact that if two figures are similar, then their corresponding angles are congruent and their corresponding sides are proportional. We have looked at, let's see, we have looked at the formula for scale factor, which is the length of an image piece over its corresponding pre-image piece.